Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed about the set interface where the implementation classes such as linked hash set and hash set. I hope you have watched that video. If you did not watch that video and if you don't know about hash set and linked hash set, I sincerely request everyone to go back and watch that video and come back to this video. In this video, I want to discuss about the list interface. In the list interface, I want to discuss about two classes. One is stack class and then linked list class. So I sincerely request everyone to watch the complete video for better understanding. First, let me discuss about the stack class and then I will discuss about the linked list class. Now, if you know, the stack follows the principle called last in first out. So the stack always follows the last LIFO, which is nothing but last in first out. Okay, so what is this one? Let me discuss by making it into full screen so that I can write something here. So if you look at, let's take that there is a set of plates you are keeping at some point. Let's take that you have kept plate number 1. On top of that one you have kept the plate number 2. On top of the plate number 2 you have kept the plate number 3, and then you have kept the plate number 4. Now which plate you can remove first? You can remove the plate number 4 first. So that is what? Which plate you have kept at last? Plate number 4. So last in first out. So which plate you have kept at last, that plate you can remove. Okay, now if you remove the plate number 4, what are the plates are there? Plate number 1, plate number 2, plate number 3. Now which plate you can remove? Next you can remove the plate number 3. Okay, then you can remove the plate number 2, then you can remove the plate number 1. Suppose let's take that plate number 1, plate number 2, plate number 3 is there. Now you want to keep the plate number 5. Where you can keep the plate number 5? On top of the plate number 3 only. So what is the issue with the stack is that both insertion and deletion can be performed on one side only. Either you want to insert new plates or new objects, that you can do after the plate number 5. If you want to remove any particular plate, first you have to remove the plate number 5, then plate number 3, so on. So the stack follows the principle called last in first out, or I can say first in last out. Now you have a doubt, sir, how can you insert the elements into the stack? We have various methods. One is push. Push is nothing but inserting the element into the stack. If you want to remove any element from the stack, we have to use a method called pop method. Okay. Similarly, if you want to verify is the stack is empty or not, then you can use the method called isEmpty. If you want to find how many elements are there in the stack, then you can use a method called size method. Similarly, if you want to know whether the particular element is there at which index, then you can use search. Okay, so all these methods we will discuss one by one. So I hope you have understood the theoretical concept. Let me discuss practically. So I will go to the desktop, Java programs. There I will open the new text document and I will save this one as stack demo. Okay, let me keep it as stack demo.java. Okay, then I will open the stack.demo in Notepad++. Now I can write the programs. First, what I need to do, I need to import the util package, so which is there in the Java package. So I need to write import java.util. Okay, star. Okay, then I will write class stack demo, then I will write public static void main string aux. Okay, then I will write stack. I want to store collection of integers, so I will write integer some s is equal to new stack integer, and then I will end with a semicolon. Now first I can verify is the stack is empty or not. Look at here, if s dot is empty, because right now you have not inserted any elements. Then you can simply write system dot out dot println, you can say stack is empty. Okay, end with semicolon. Let me close the main method, let me close the class. Okay, now I need to compile the program, so I need to open the command prompt. You know that all our programs will be there in the desktop, Java programs. So I will write cd Java programs, then I need to compile the program. So I will write java c stack demo dot java. There is no errors. Let me run the program. So Java stack demo. See, you got the output as stack is empty because we have not inserted any elements. Okay, let me remove this one and I want to insert some elements. So if you want to insert any object into the stack, then you need to use the method called push method. Let me insert 97. Okay, and similarly I want to insert 99. Okay, I want to insert 100. Similarly, can I insert null or not? We will verify. Yes, we can insert null. If you want to display the elements which are there in the stack, so you can simply write system.out.println yes. Now you can see, even I want to verify one more thing also. What is that? Will it allow me to insert the duplicate elements or not? Let me enter 97. Okay, now the stack follows the what order? First in, last out. So if you look at the elements currently what are there, okay, so first element you have inserted is 97, so 97 will be the bottom, then 99, then 100, then null, at last you will have the 97. So this is the bottommost element and then this 97 is the last element. Okay, if you have a doubt, let me insert one more element. So I will write simply, otherwise you will get confused. Okay, s dot push, okay, something 78, let me write. Okay, then topmost element is 78 only. Okay, so let me save the program and compile it, and we got an error. I think we have forgot to end with semicolon. Okay, so now let me compile the program. There are no errors. Let me run the program. Okay, we got the output as 97, 99, 100, null, 97, 78. So what is the point you have understood from this one is we can insert the null object, and also duplicate objects are also allowed. Okay, now even if you want to verify is now the stack is empty or not, so what you can write, s dot is empty. Okay, is empty. If so, you can say stack is empty, else I want to print the topmost element. Okay, so I will write stack is empty. Okay, else I want to print the topmost element, so I will write system.out.println. Okay, the topmost element is the topmost element in the stack is. Okay, I will write plus s dot, there is a peek method which will display the topmost element in the stack. Okay, now look at here, let me save the program, let me compile the program again. Oh, I am habituated with the Python, that's why I am doing these mistakes. Okay, let me compile the program again. There is no issue. Let me run Java stack demo. Now you can see the topmost element in the stack is 78. Okay, I hope you have understood this one. Now we have done till now. Let me start removing the elements. Okay, so what I will do, I will cut this one somewhere we can use it. Okay, now I want to display all the elements. First, system.out.println. Okay, I will write yes, ends with a semicolon. Then I will use the pop method. Okay, if you simply say pop, then topmost one will be removed because stack follows the last in first out. So you can write s dot pop Okay, now look at here. What is the topmost element right now? 78. So now 78 will be removed. And the next topmost element after removing the 78 is 97. So 97 will be removed. If you simply say, okay, system.out.println, okay, after performing pop operation twice, okay, then you can write plus. Now look at here, what are the elements will be displayed? Can you guess? Look at here, you have the 97, 99, 100, and topmost element will be null. Okay, let me save this program, compile the program. Okay, let me run the program. Now you can see earlier the elements are 97, 99, 100, null, 97 and 78. After performing pop operation twice, so you have successfully removed 78 and 97. So the remaining elements are 97, 99, 100, null. Okay, so we have discussed about the push operation, pop operation and peek operation. Now I want to verify whether the particular element is there or not, okay, or particular object is there or not. So I will write system dot out dot, okay, println, okay, and I will write the object 99 is at, okay, I will write plus s dot search. I want to search whether the object 97, 99 is there or not. If it is there, at which location it is there. Let me save it. Okay, now you look at what are the elements are there: 97, 99, 100, null after performing the pop operation twice. So 99 we are searching, it is there. Let me run the program so that you can see the output. Java stack demo.java, then Java stack demo. See, you got the output as the object is at 3. Why it has given the object at 3? It will follow the lost in first out. So that's why you have null, 100, 99. So it will follow the what order? It will follow the lost in first out, and the index will start from 1. So the topmost element is 1. The next element 100 is at 2. The next element 99 is at 3. Next element 97 is at 4. If you have a doubt, you can search 97 is there at what? Okay, you can write s dot search 97. Now you can again compile the program. Let me run the program. Okay, now you can see 97 is at 4. So it will start from lost in first out, means from the topmost it will come. So null is at index 1, 100 is at index 2, 99 is at index 2, index 3, and 97 is at index 4. Okay, now I want to find how many elements are there. Okay, so I will simply write the number of elements or the number of objects in stack is, okay, I will write s dot size. Size will give you the number of objects in the stack. Okay, let me save the program. Let me compile the program. What is the issue we are facing? We have ended with semicolon only. What happened? Oh, we forgot to provide the concatenation. Okay, let me compile the program again. There are no issue now. Let me run the program. See, the number of objects is, the stack is 4. One is null, 100, 99, 97. So I hope you have understood about the stack class. Now let me discuss about the linked list class. Okay, the issue with the stack is you can push the elements or pop the elements from one direction only, whereas linked list we can do from any location. That we will see now. Okay, let me delete all these things and let me discuss about the linked list. Linked list class we will discuss. So first let me discuss the properties about the linked list. What is the underlying data structure it will follow is, it follows the data structure called double linked list. I think everyone know double linked list if you know the data structure concept. Okay, double linked list will have a node consists of three elements. One is the address of the previous element, the value, and then address of the next element. I will discuss all these things. So first let me discuss the points about the linked list class. The data structure it follows is double linked list. Insertion order is preserved. Insertion order is preserved. Insertion order is preserved means how you are inserting, the same way the elements will be displayed. And even as the stack, linked list also allows the duplicate elements. So duplicate objects are allowed. Okay, sometimes I use the word elements, but the proper word we should use it as an object. So duplicate objects are allowed. Even null insertion is also allowed. Okay, is it clear? So now let me keep a new slide and go to the slideshow, and so that I can discuss about the double linked list. As I said earlier, linked list follows the data structure which is a double linked list. Double linked list, a node will have three elements. So one is address of the previous element, value, and address of the next element. Let me take three nodes. Okay, let me take three nodes like this. So this one is 100. Let's take that address. This is 200 and this is 300. So address of the previous, suppose this is the first object, then address of the previous one will be null. There is no previous node. And this, let's take that this is 10 and address of the next one is 200, and take this one. This is having the value 20. This is having the value 30. So this will be connected to like this, and this will be connected to like this. So both we can follow the forward movement and also backward movement. Okay, so now address of the previous one is 100 and address of the next one is 300, and address of the previous one is 200. Address of the next one is not there, so null. So this one will be connected like this, and this one will be connected like this. If you want to insert any element either or any node at the start, that also you can do. You can add one more and you can create like this. So address of this one, suppose let's take this is 1000, so the 1000 will be placed here. Okay, suppose if you want to insert any node at a particular index or after particular one, then suppose let's take after this node you want to insert, then this address will come like this address will come like this, and this one will become, this one will become. So it is like you have a one node, you have already one node, now you want to insert another node. So like this it will be coming. Okay, so I hope you have understood. And even it is possible for us to insert a node at the last. So whereas in the stack, insertion and deletion, or I can use the technical term called push and pop, can be performed on the top. Whereas in linked list, we can insert and remove from any location. Okay, so I hope you have understood about the double linked list and theoretical concept related to the linked list. Now let me discuss about the program. Okay, so what I will do, I will go to the desktop Java programs and I will open the new, let me open the new text document and save it as linked list demo. Okay, .java. Let me press yes. Okay, and I will open this one using Notepad++. Okay, I think you can see this one. So I will write import java.util.star, and then I will write what is the class linked list demo, then public static void main, and then you have to write string args, and now I need to write linked list. Okay, then I need to store the objects of integer, so I will write integer some linked list. I will write ll is equal to, or simply let me write l. Okay, I think you can clearly see it as it is an L. Okay, new linked list, okay, integer, and then I'll end with the semicolon. Okay, now I want to add some elements, so then I can write L dot add 1, then L dot add 2. Similarly, I want to add L dot add, I want to add 100 at the index 1. Look at here what will happen. Similarly, I want to add a particular object at first location. So which one I want to insert? Let's take that 4. Then similarly, I want to add another one at the last. Okay, so I will use a method called add last. Okay, let me add at 5. Okay, so we have totally 3 methods are there. One is add, and even you can use add method with the 2 parameters, add first and add last. What this will do, I will discuss now. Add will simply add at the end, meaning is that let's take that you are adding 1, so 1 will be the only node will be currently having, meaning is that address of the previous node and address of the next node will be null. Okay, then you are adding 2, so 1 is already there, 2 will be coming after 1. So this 1 is there at the index 0, this 2 is there at the index 1. Now you are asking to add the 100 at the index 1. So already at index 1 2 is there, so you need to add 100 then 2. So 100 will come in between 1 and 2. Okay, now you are trying to add a particular object 4 at first. So already at first 4 is there, so I will keep 1 is there, now I'll keep 4. Then other elements will be, what I can say, shift will happen. Okay, so you have 4 100 2 is there. Now you are asking me to add an object 5 at the last, so 4 100 2 5 will be there. If you want to display the output, then I can write system.out.println. okay, then I can write what, L. Okay, even you can display all the elements using the for loop, iterator, list iterator also. Those things also I will discuss. Okay, let me compile the program. So let me compile, let me clear the screen first. Okay, Java C, okay, Java C linked list demo, linked list demo dot java. Okay, what happened, we forgot to end with semicolon. Okay, let me write system.out. Okay, even we did lot of mistakes, we did not end the main and we did not end the class. Okay, these things will happen. Okay, let me compile the program. Now there are no issues. Let me run the program, Java linked list demo. Okay, now we got the objects as 4 100 2 5. I hope you have got the point. Okay, so this is the way you can insert or add the elements in the linked list. Now I have 3 more methods. What are the 3 more methods? Are get method is there, get first method is there. Let me write get first and then get last. What these 3 methods will do? The get method, suppose if I provide some index 1, so at index 1 what element is there that will be displayed. Get first means what is the first element is there that will be displayed. Get last means what is the last element is there that will be displayed. If you have a doubt, let me write a small piece of code to explain this one. Let me write system.out.println. The first element in the linked list is, okay, I should write plus performing the concatenation, then I need to use get first method. Okay, let me copy this one and paste it. The last element in the linked list is, so L dot get last method, LAST. Okay, similarly I want to find the element which is there at the index 2. Okay, so let me write the element at index 2 is so I need to write get. Here I need to provide 2 value. Okay, I need to provide the value 2. Let me save the program, and now let me compile it, and now let me run this. See, we got the first element in the linked list is 4, the last element in the linked list is 5, the element at index 2 is 100 because the index will start from 0. This is at 0, 4 is there, at index 1, 1 is there, at index 2, 100 is there, at index 3, 2 is there, at index 4, 5 is there. Okay, so I hope you have understood about the get method, get first method, and get last method. Now let me discuss about the remove method. So you have remove, okay, and then you have remove with some integer value, okay, and then remove first is there, and then remove last method is there. I think now you can understand what the remove method will do. The remove method will remove the first element. Suppose if you say remove some integer value, let's take that you have given 2 at index 2, what element is there or what object is there, that will be removed. Remove first means first element will be removed. Remove last means last object will be removed. If you want to verify, you can write it system dot out dot println. Okay, I will simply use remove. Okay, then I will print this one. Okay, before that let me print the elements here. Okay, now I am writing system.out.println remove. Then again let me print system.out.println. Okay, L. I want to see how many remaining elements are there. Then I have written, oh, I need to use the remove method, right? This is the remove method. Okay, now let me copy and paste these things. Okay, remove at index 2, what element is there. Okay, after that I want to print all the elements which are there in the linked list. And then I want to remove the first one, so I will write, okay, and remove method also you need to write L dot. Okay, this also L dot, and here also L dot remove first. Okay, remove first, and then again I will print the elements. Then I will use remove next. Sorry, not next, last. Okay, L dot remove last, and then I want to print the elements. Look at here. Let me save this program, and now let me compile the program. There are no errors. Let me run the program. Now you can see initially you have the elements 4, 1, 100, 2, 5. Then you have get the first element, last element, and index 2. Then you have the elements 4, 1, 100, 2, 5. Then what you are saying? You are simply using the remove method. What the remove method will do? If it does not pass anything, what it will do? It will remove the first element. The first element is 4. So the 4 was successfully removed. Then the remaining one is 1, 100, 2, 5. If you say remove with a particular index, at index 2, what is there that will be removed? So look at here, the elements are 1, 100, 2, 5. So at index 0 you have 1, at index 1 you have 100, at index 2 you have 2. So the 2 has been removed. If the 2 has removed, what are the remaining elements? 100, 5. Okay, then what you are saying, remove first, which is the first one? 1. So that has been removed successfully. So then you have 105. Then what you are saying, remove last. So that one has been removed. Okay, is it clear? 5 has been successfully removed and the remaining elements are 100. Okay, now you can use the is empty method. Okay, you want to verify whether the list is empty or not. So L dot is empty. Okay, method. If it is empty, then I want to print system dot out dot println linked list is empty. Linked list is empty. Else I want to write system dot out dot println and I want to display the number of elements. So the number of elements is, okay, I will write plus L dot size. Okay, size method will always give you the number of elements. Okay, so how many elements are left? Only one element is left, so we will get an output as 1. Look at here. So at last the number of elements is 1. I hope you have got the point. Okay, let me remove all these things. Okay, we have added some elements, so right now you have 4, 100, 2, 5 is there. If I want to display all of them using for loop, then what I can write? For, okay, integer some I, and then I will write L. Okay, then I can open the for loop. I can write system.out.println. Okay, I can simply display I, end with semicolon. Let me close the for loop. Now let me save the program. So all the elements in the linked list will be displayed one after another. Okay, Java C linked list demo.java. Now Java linked list. Now you can see 4, 100, 2, 5. Even you can display the elements using the iterator also. Let me write system.out.println displaying elements using iterator. Okay, let me write this one. So what is it? Iterator L something A is equal to I dot iterator. Okay, I dot iterator. Then you know that iterator has two methods. One is has next and next. Has next will verify whether the next element is there or not. Then next method will display the next element in the list. So I will write while, okay, a dot has next method will verify whether the next element is there or not. Then I will open the while loop, and then I will write, okay, what is that? A dot next method I will use, and I will close the while loop. Let me save this one and let me compile the program. Okay, no, it is not I, it should be L, because on the linked list L we are doing. Okay, so let me save it and let me compile the program again. Java linked list. Okay, Java linked list demo. Okay, see, displaying elements using iterator 4, 100, 2, 5. Even we have the list iterator also there. What is the beauty of the list iterator is that it will display the elements in both the direction, forward direction and also backward direction. How it will be done? Look at here. You have list iterator. Okay, list iterator. Let me write it as some B is equal to, on what you want to do, on L, and then you need to write list iterator, and then I will write, I will display the elements like this. Okay, system.out.println, I will say displaying the elements in forward direction, so that you will understand, in forward direction. Then I will use has next and has next. Okay, so while b dot has next, so it will have totally 3 methods will be there. Has next, whether the next element is there or not. If it is so, you can display the next element by using the method called next. Similarly, has previous method will be there, so you want to verify whether the previous element is there or not. If it is there, you can display the previous element using the method called previous. So totally 4 methods are there. Okay, now I can write here, let me copy this once and I can paste it instead of typing again. Okay, so here what I need to write, b dot next. Let me end with the semicolon, semicolon, and close the braces. Now let me compile the program again. Okay, let me run the program again. You can see displaying the elements in forward direction. So 4, 100, 2, 5 is there. Similarly, you can display the elements in the backward direction also. Let me copy and paste here, and here I can write displaying the elements in backward direction, and here I need to use has previous method, and here I need to use previous method. Okay, let me save it, and now let me compile. Okay, there are no errors. Let me run the program. Now you can see displaying the elements in backward direction. We got 5, 2, 100, 1, 4. I hope you have understood about the linked list. If you still have any doubts related to the stack class and linked list class, you can ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.